Alright, so today we're going to talk about adding and subtracting radicals. Now, 2 days ago we talked about radicals being treated an awful lot like variables. So you cannot add or subtract radicals that are not identical. And that's just a rule we have to remember. Just like with variables, you can't add x plus y. It's just x plus y. You can't combine them. So we're going to use that in solving these three problems and then two more that include fractions. So my first problem, I have 15 times the square root of 2 minus 8 times the square root of 2. The first question you have to ask yourself is, are the radicals the same? They are. They're both the square root of 2. So if I have, I'm going to turn this into a variable expression really quickly. A similar variable expression, and then we'll take a look at this problem in particular. So if I had 15x minus 8x, how many x's would I have? 7. The answer would be 7x. Well, the same thing applies here. If I have 15 times the square root of 2 minus 8 times the square root of 2, I have 7 times the square root of 2. And that's it. So that's the most basic problem that we could talk about. If it was addition, you just add them, obviously. And we can get a little more complicated from here. For our next question, we have 5 times the square root of 192 minus 7 times the square root of 3. So are the radicals identical? No. But we may be able to simplify one or both of the radicals so that we would be able to combine them. So we have to look at the square root of 192 and the square root of 3. Well, 3 is a prime number, so we can't break that down any further. So we have to take a look at the square root of 192. What goes into 192? Now, there's a very good bet that since we are being asked to subtract something that has the square root of 3, there's a good bet that 3 goes into 192. And you would discover that 3 goes into 192 64 times. So the square root of 192 is equal to the square root of 64 times the square root of 3. Well, Duncan, what is the square root of 64? It is 8. It is 8. So 8 times the square root of 3 is equivalent to the square root of 192. So I'm going to substitute in 8 times the square root of 3 for the square root of 192. So we have 5 times the square root of 192, which we're going to write as 8 times the square root of 3 minus 7 times the square root of 3. Well, what is 5 times 8? 40. So we have 40 times the square root of 3 minus 7 times the square root of 3. Now are the square roots identical? They are. So we have 40 times the square root of 3 minus 7 times the square root of 3, and we get 33 times the square root of 3. So that had one extra step on our original problem, but it wasn't really too bad. Our third question, and I'm going to clear off everything we've done. Our third question, we have 3 times the square root of 24 plus 4 times the square root of 150. Are the square root of 25 and the square root of 150 equivalent? No. So we need to simplify these radicals so that we hopefully can then combine them. So let's take a look at the square root of 24 and the square root of 150. So boys, I want you to simplify the square root of 24. Girls, I want you to simplify the square root of 150. All right, Audrey, are you ready? Any takers on the square root of 24? Okay, Eli? 2 times the square root of 6. Because square root of 4 times the square root of 6 is 24, square root of 24. So that works out. What about 150, Sarah? 5 root 6. Look at that. Our square roots are identical, aren't they? So I'm going to rewrite this expression down here, but instead of the square root of 24, I'm going to substitute this value. Instead of the square root of 150, I'm going to substitute that value. So I have 3 times 2 times the square root of 6 plus 4 times 5 times the square root of 6. What is 2 times 3, or 3 times 2? 6. So we have 6 root 6 plus, what's 4 times 5? 20 root 6. So 6 root 6 plus 20 root 6 is 26 root 6. And there's your answer. Simple. So let's take this idea to slightly more complicated problems. All right, so now we have fractions as well as a problem that has several square roots in it. So the square root of 2 over the square root of 7, I'm going to rewrite as this. Because we know we can distribute the square root to the numerator and the denominator. So when you're subtracting fractions, what must be true? No? They need to have a common denominator. So what is going to be the common denominator? 14, or the square root of 14 in this case. So I'm going to multiply this first term by 1 in the form of the square root of 2 times the square root of 2. Well, what is the square root of 2 times the square root of 2? It's 2. Because square root of 2 times the square root of 2 is the square root of 4, and Miles is going to tell us that the square root of 4 is 2, right? All right. And Miles gives us the thumbs up, so it must be right. So we have 2 over the square root of 14, because 2 times 7 is 14. And we're subtracting that by, well, I'm going to have to multiply this term by 1 in the form of root 7 over root 7. So root 7 times root 7 is 7. The square root of 2 times the square root of 7 is? Now, we can add these because the denominators are the same. So what is 2 minus 7? Sorry. So we're going to subtract the numerators. The denominator stays the same. So what is 2 minus 7? We have negative 5 over the square root of 14. Now, all of you are going to be telling me that if I keep the answer like this, I'm going to be dragged off into the county pen because you have a square root in the denominator. You can't have that. So what am I going to multiply by so that I can get rid of the denominator, the square root in the denominator? That's right. I'm going to multiply my answer by 1 in the form of the square root of 14 over the square root of 14. What is the square root of 14 times the square root of 14? 14. It's just 14. What is negative 5 times the square root of 14? That's right. Negative 5 times the square root of 14. And so there's my answer. I have successfully subtracted those two fractions, and I don't have a square root in the denominator. We're going to try one more problem. Are you ready, sir? Are you excited? Okay. Somehow I don't quite believe you, but I will press on anyways. All right, so now we have 3 root 3 minus 2 root 12 plus 4 over the square root of 1 over 3. Do we have any square roots that are the same? Not so much, do we? No. All right. So 3 is a prime number. What about 12? Can I reduce 12? 6 and 2 go into 12, but neither 6 or 2 are perfect squares. What else goes into 12? 4. So this is just equal to 2 root 3. So we have 2 times 2 root 3, because 2 root 3 is equal to 12. What is 2 times 2? So we have 4 root 3. I'll rewrite everything I have so far. So can I combine these two terms? Yeah, because the square root's the same. 3 root 3 minus 4 root 3 is negative 1 times the square root of 3, so I don't have to write the 1. And I still have the plus 4 square root of 1 over the square root of 3. Now, am I able to combine these so far? No, not so much. What I find even more disturbing, and I'm sure you are totally disturbed by this too, is we have a square root of 3 in the denominator. That's just not right. It is hardcore. So what am I going to do to this fraction, this 1/3, the square root of 1/3, so that I don't have a square root in the denominator? Maura?
Multiply by square root of 3.
Yeah, so I'm going to multiply this fraction by the square root of 3 over the square root of 3. So square root of 3 times the square root of 3 is 3. So I have 4 times 3 in the denominator. What is the square root of 1 times the square root of 3? Tell them it's coming. So we have negative square root of 3 plus 4 times this fraction. Well, if I'm adding things and one's a fraction, what must I do with this? Make it turn into a fraction. In fact, to add two fractions together, what must be true? I'm hearing lots of people mumbling the correct answer, but no one loud enough that I can actually hear it. Common denominator. So what am I going to do? So the common denominator is obviously 3, right? So I'm going to multiply this by 3 over 3. So I get negative 3 root 3 over 3 plus, well, I have 4, and I need to turn that into thirds. So 4 times 3 is 12, right? So I have 12 root 3 over 3. What is 3 root 3 plus 12 root 3? There you go, 9 root 3 over 3. But wait a second, does 3 go into 9? It does. How many times? 3. So we end up with 3 root 3 after all of this, because this piece here reduces. And that's it. Are there any questions?
That was a